Okay, so we're going to look at hydrocarbon compounds. These are pretty simple molecules. You'll see just based on the name there what elements they contain. These are molecules. These are covalently bonded things, just a specific category of them. So first and foremost, organic compounds. These are all examples of organic compounds, and these are all compounds that contain carbon. And the big thing to remember when we're talking about organic compounds, these are molecules, which means they're covalently bonded. Because there are compounds out there that do contain carbon that are not organic. Something like calcium carbonate, so that's limestone, or something like sodium acetate, which is the vinegar flavor in salt and vinegar chips. These contain carbon. There's carbon there. There are two carbons, sodium acetate. But these are both examples of ionic compounds. These are not going to be organic molecules. So what we're focusing on, simplest organic compounds, only contain hydrogen and carbon as the elements in there. And they have a very specific name, very easy to remember. These are hydrocarbons. And you wonder why that is. Well, look at the elements that are there. You have hydrogen, you have carbon. Don't overthink this. There's not that much there. So we're going to focus on how to name these, how to categorize them, and we're going to be using some prefixes, and they are named based on the number of carbon atoms in the longest chains. Basically, like more carbon atoms you have, different prefixes we're going to use. The first four of these, I would argue, are a little bit weird. They don't really relate to the number there, one being meth, 2 eth, 3 prop, and 4 bute. These are definitely not really related to the number. However, you look at 5 and it's pent, you look at 6 and it's hex. These are more what you would expect. So just remember you have this reference here. You'll be able to turn to that if you're not quite sure what something is. So that's the prefix. That's the first part of the word. And we need to look at the second part of the word, which our ending is going to be based on the types of bonds that are there. So you read this and it says, so if the carbon atoms are bonded with single bonds, we end its name in ane. So we look at the examples at the bottom here. We have the first one. There's all single bonds surrounding it. We're talking the one on the left. We've got one carbon, and it's all single bonds. So this is like the easiest case because, well, there's only one carbon. It's not bonded to anything besides the hydrogens. We have the one of them, and that's that meth prefix. Make any jokes that you want. And then the all single bonds thing, like we just described, all single bonds, ending is going to be ane or ane, and this is methane. And so this is a major component of natural gas, methane, very combustible. We burn it for energy. We would also say that this is an example of a saturated hydrocarbon because, well, you look at it, there is no way we could fit more hydrogens on it. There's 4 hydrogens, it's obeying the octet rule. This is considered to be saturated. All right, let's go to the other end on the right here. And it says if the carbon bonds have a double bond in its name, it's going to end in ene. So we have that occurring in the third one, the one on the right. If you look, we've got 3 carbons. So that's going to be that prop, might look like prop prefix, and there is a double bond present there. So that's going to be prop, and the ending is going to be ene. And that's all we really need to do with that. 3 carbons gets you the prefix. The double bond is going to get you that ending. So last one here, a triple bond is going to end in ine. So if you look at the middle example, we've got 2 carbons, and there is a triple bond. So we can name this, for the 2 carbons, that is the F prefix. And it says here a triple bond will end with -ine. So we have Y and E, and we have our compound ethyne. You might see this same compound named acetylene, same name, different compound. It's used in torches if you ever do any welding. Maybe you will, who knows. So these 2 on the right with the triple and the double bond here, the ethyne and the propene, these are both unsaturated hydrocarbons, because if they didn't have those additional bonds, whether the triple or the double, if those bonds weren't there, there could possibly be more hydrogens bonded there. So we didn't max out the number of hydrogens. We didn't saturate these compounds with hydrogens. They have a double or a triple bond instead. And there are general terms for the categories here. We would say our first one, methane on the left, this is an example of an alkane. So this is just like the big overall category. So alkane compounds are those only single bond compounds. On the right, propene is an example of an alkene compound. So same hydrocarbon, carbon hydrogen, only with a double bond somewhere in that chain. And then our middle one is an example of an alkyne compound. And you can see it really just matches up with the ending. Methane as an alkane, propene as an alkene, and then ethyne is an alkyne. So just, categories, if we talk about something as being one of these types of compounds, it's just saying, hey, single bonds versus maybe a double bond versus maybe a triple bond, just paying attention to those names.